Good day. Answer any question. This is question number 2 of November 2022. That is grade 11 paper 1. A pulley system is used to keep a heavy object at rest as shown in the diagram below. So sinale diagram upper which is hanged here and it's at rest, meaning that the net force of the system will be equal to 0. So we can draw a closed vector diagram. Okay, so classes over a closed vector diagram. Siqala free body diagram. So free body diagram, there is this force. This is the tension force. Let's say T1, which means this one is T1. T1 is equal to 1,410 foot. Then spenal nentambo. So there's a tension that is, let's say this one is T2, which means this 1,284.95 is our T2. Then this object also have the weight, so we also have Fg. So the free body diagram will be like this. So it's not T1, it's not T2, it's been a weight that is Fg. Okay, so class over a closed vector diagram, we are drawing a triangle. So a triangle, that is even angles as we can say A, B, C. So class a calculator using a triangle, we are going to use sine rule. What angle A divided by side opposite to A, that is small letter A, is equal to angle B. This is B divided by the side opposite to this angle, so small letter B. Okay, so we have the free body diagram now. We are going to change that free body diagram to a closed vector diagram. Let's just go straight to the question. The first question says, define the term resultant force. The resultant force is the vector sum of two or more vectors.
Yeah.
So that is the vector sum of two or more vectors. So divine side vectors, then we get the resultant vector. The following question again, we will draw the vector diagram showing the forces acting on an object. Label the forces and indicate the angle on the diagram. So you must also include the angle. So we are going to use that free body diagram to draw the vector diagram. The vector diagram is a closed vector diagram, that is the triangle. This is what using the line. Okay, so we're going to use it. So we have a force that is going down, then it's a force air in this direction. So this is the downward force, then another force in the other direction, which we can say is T2. This one is a weight, that is Fg. Then we have a force that is landed to that direction, so that one is T1. So we have T1. Remember, this one is vertical, the vertical force. Now we need to write the angles. So masikhangele angles. Let's go back to the diagram. So classify with diagram, we have the vertical line. This is the vertical line which is going down. Okay, then between the vertical line, that is Fg, this is our Fg, and T2, Fg and T2, there is this angle this angle, which is 40. So we have 40 degrees between T2 and FG. So since we're 40 up, now that is about 40 because match it vertical opposite angles. So we have 40 between T2 no FG. So this is T2, this is FG. So we have a 40 degrees here. Right? Now let's go to another angle. So we need this angle first. We know that upper is somewhere and down 90 degrees, which means if this one is 55, therefore this one is 35 degrees. 35 degrees. Now, siwena lo mgca ke. Lo mgca umele bani u-T1. Between T1 and FG, there is this angle. This angle is 35 vertical opposite angles, which means between T1 and FG, there is what? 35 degrees. Oh, degrees, I mean, that is the angle. Now we're left with this angle. Now that we have two angles, the sum of angles of a triangle is equal to 180, which means when we add 35, same D1 is 35 no 40 degrees plus the angle singayazi. Let's say the angle singayazi angle B. For example, let's say this one is B. So this one is A, this one is C. So it's angle B. So you transpose as with 2, then you press the calculator, then you get B, which is supposed to be 105. So the angle here is 105. Okay. Now we're going to use this vector diagram. Remember we said if we need a triangle, you can use, in fact we use here the sine rule. This question says calculate the weight. This is the weight. Do we have a mass of an object? Let's go to the diagram. There is no mass there. Even in statement, ayikho mass, which means we are going to use as forces. Remember that T1 is equal to 1,410 newtons. Then T2 is also given 1,284.95 newtons. So we can use this triangle to get this one. Okay. Sine of angle A divided by small letter a is equal to, we're looking for G now, which means the angle sine of B divided by small letter b. Now let's substitute. This is our A, this is angle A, so we have sine 35 there. 35 degrees over the side that is opposite to A is T2. T2 is 1,284.95, which is equal to sine B, angle B, this is our B, so it's 1 sine 105 over A wethu ibe ngubani ke ngube ngu-FG. FG lo simfunayo, then we cross multiply. So when we cross multiply, this will multiply that one and this will multiply that one. So we have FG sine 35 degrees, which is equal to this times this one, so 1,284.95 sine 105. Then we divide by sine 35 both sides. Sine 35 degrees, so this cancels that, then we get FG. That is the answer. Then let's go to question number 2. Oh, it's question number 3. Question number 3 is Newton's laws. two blocks, another blocking 5 kg, another blocking 2 kg are connected by a light inextensible string. A force F is applied on 5 kg at an angle of 20 degrees to the horizontal, and the system of the blocks accelerates to the right at, so we are given the acceleration, which is 2 meters per square second. The kinetic frictional force is also given, 5 kg in 10 newtons. So the best way is to first draw the free body diagrams. So on a free body diagram here, there is a tension here. It's added a phezulu tension. So we also have the weight of 2 kg. So if free body diagram here, we have a tension, then we have the weight, that is Fg. Size kulena ke ngoku u5 kg yena unale tension imtsalela ngapha, that is the tension. Then there is a friction, so is opposing the motion because it accelerates iyaphi right, therefore friction is opposing the motion, so it's no Fk. We have a normal force which acts perpendicular to the surface and object in contact with it. Then also have Fg nala, then another force applied. Then if free body diagram yethu ka 5 kg zoma kanje, we have the force that is applied, then sibe ne normal force pha, then sibe ne friction ne tension yakwecala, that is tension and the friction, then sibe nobani, sibe ne weight here. That is the free body diagram for 5 kg. Masiye questions again. The first question is define the term normal force. The normal force is defined as a perpendicular force that is exerted by a surface on an object in contact with it. It's a perpendicular force that is exerted by the surface on an object in contact with it. Then we have the following question. Draw the labeled free body diagram. Draw a free body diagram of all forces acting on an object. So we are going to label it. There are 5 marks, 5 kg block, meaning that if forces as leader must be 5. So we have this one, 1, 2, 3, 4, 5. There are 5 forces. So that is the free body diagram. But let's draw it here. So it's 3.2. Let's start with that one of 2 kg. Silungiselele ubala. 2 kg is very easy. Sesizobile, so I will just copy. Sinala tension inyukayo, sibenala Fg, which is going down. Then sibhale lapha 5 kg. Oh, that is 5 kg. Sorry. 5 kg. So eka 5 kg ngoku free body diagram, that is 5 kg. Bullet ka 5 kg, then force enyukayo, which is a normal force. Then another force here, that is a force applied. Then we have a tension, we have a friction, so we have a tension and what, and a friction, so spin a weight. So eyona ndiyithanda kakhulu ke mna, when you see components, force that is slanted, engekho vertical, engekho horizontal, yenza forces that will be vertical and horizontal. So we have a vertical component that is Fy and a horizontal component that is Fx. Then you remove the original. This is the free body diagram I like, but nalebe sizobe uqala correct. Okay, so izosinceda kwi-calculations le. The first question lapha ithi make calculate i-tension. Calculate the tension on the string. Now if we can look here, we have a weight because we do have a mass. We do have a mass and g. So masibale ke ngoku. So a mass is 2, then g 9.8. Then we get 19.6. So it's 19.6 newtons. So we are going to use this one because we are looking for a tension and sesna FG. So ilula le sewenzise. Then if we have two unknowns, then just another equation. Okay, let's start with the simple one. Let's work on it. That is 3.3.1. Calculate the tension. F net is equal to MA. So the object lena mover in this direction, accelerator to this direction, which means lena accelerator upwards, meaning that the acceleration must be positive, therefore the tension must be positive, therefore this one is negative. So tension minus Fg is equal to MA. Okay, tension is what we're looking for. Then Fg is this one, so it's 19.6, which is equal to mass is 2. Then the acceleration was given. Let's go back to the statement just to confirm it is 2 meters per square second. This is the acceleration, 2 meters per square second. It's 2 meters per square second. Then we transpose. Okay, so the tension will be equal to let's press calculator. We will transpose this one to 4. Let's press the calculator. So the tension is 23.6 newtons. That is the tension. Now let's go to another question. The second question says calculate F. So F is here because we know this one is F cos theta. Lena yona is F sin theta. So we can use horizontal, we can use vertical. Now let's say we use vertical. We will need the normal force Fy, Fg. We do not have the normal force. But if we use this one, if we use this one, that is the horizontal forces. If we use the horizontal forces, we given they give us what the kinetic friction, the tension is already calculated, so that will be very easy. We do have the angle. Let's go up and check the angle. The angle is 20, as you can see. So we have 20 degrees, that is the angle. So we're going to use horizontal forces, not vertical forces, but we stick on method here to 80. Whenever ubala on Newton's laws, you must write F net is equal to MA. Okay, so the acceleration is going to the right, is directed to the right, meaning that this one must be positive, these two must be negative. So see, no Fx, which is a positive, minus a tension minus Fk, which is equal to the mass times acceleration. Now this one is F cos theta. This is the formula, minus the tension minus Fk. Then you get MA. So the force is what we are looking for. That is a force cos, the angle is 20, minus the tension is this one, that is 23.6, minus the friction was given on the statement 10, so must wheel back to the statement just to confirm the frictional force. The kinetic frictional force on 5 kg block is 10, so the frictional force is 10. Okay, is 10. So the mass is 5, the acceleration is 2. Then we press calculator here and we transpose. Okay, let's press calculator. So we have 43.6, then we divide by cos 20, then we get F, then we divide by cos 20, then we get F as 43,6 newtons. That is F. F is equal to 43,6 newtons. That is F. Let's check another question. This following question says calculate the coefficient of kinetic friction. So we are looking for this one, coefficient of kinetic friction, that is 3.3.3. We have the kinetic frictional force as 10 newtons, which means we are going to use the formula, this formula, but we do not have the normal force, which means we must calculate the normal force. The easiest way of calculating the normal force is to say if forces that are directed upwards combined will be equal to the forces that are directed downward combined. So if we can go to the free body diagram, in the free body diagram we have normal force and Fy, they are directed upwards, and Fg is directed downwards, which means when you combine these two forces must be equal to Fg. So here Fg or normal force, let's go is normal force together with Fy is equal to Fg. Okay, so we are looking for the normal force, then Fy is F sine theta, which is equal to mg. Fg is equal to mg. Then the normal force is what we're looking for, plus if force that is 3,6 sine angle theta 20, which is equal to the mass of the object 5 yona less theta times g, which is 9,8. Then starting with normal force calculator, the normal force is equal to 34,09 newtons. Then this is what substitute. The friction is 10. We are looking for the coefficient of kinetic friction. The normal force is this one, that is 34,09. Then we divide by 34 both sides, 0.09. 34,09 both sides. Then we get the coefficient of kinetic friction as divided by as 0.29. There are no units for the coefficient of kinetic friction because it's a ratio of forces. Then says a question. Let's go to question number 4. Question number 4. Seeing two people upwards as shown in the diagram below. The tension in the cable is given. Now the tension is in while the helicopter is ascending at constant speed. So what we know is that once they say constant speed, the acceleration is equal to 0 meters per square second. There is no change in velocity. There is no rate in change in velocity. Acceleration is a rate at which velocity changes, so there is no change in velocity, therefore acceleration is equal to 0. This also implies that the F net is equal to 0 newtons. Okay, now the first thing that you do, you draw the free body diagram. Now if you can look here, there is a weight, ngabantu our two people, there is a what? A weight, that is Fg. Then there is this string, which means there is the upward force, which is a tension. Okay, that is the tension force. So this is very easy. Now let's answer the question. So the first question says, state Newton's second law of motion in words. Newton's second law states that when the net force acts on an object, the object will accelerate in the direction of the net force, with acceleration that is directly proportional to the net force, and acceleration that is inversely proportional to the mass of an object. So meaning that when the net force increases, acceleration increases. But when the mass of the system or of the object increases, acceleration decreases. That is Newton's second law. Calculate the combined mass. This is very easy. Follow the steps. Step number 1, you write F net is equal to ma. Then we choose the direction. This is ascending up, it's moving upwards, which means upward must be positive, this must be positive, and this one must be negative. So 4.2 F net is equal to ma. Okay, F net is equal to ma. So we have a positive tension there minus the weight, which is equal to ma. But since the acceleration is equal to 0, which means yonke le ndawo will be equal to 0, that is F net. Alright, so we can also use that thing as 80, F net is equal to 0. So tension minus Fg is equal to 0. Now we can just transpose this one. Okay, we are given the tension there, 1205,4. 1205,4. The tension is 1205,4 minus Fg, which is equal to 0. Okay, so if you transpose, you will get Fg, negative Fg, which is equal to negative 1205,4. Then we can divide by what? By negative 1. Negative 1. So Fg is equal to that tension, which is 1205,4 newtons. But the question says calculate the mass. Now that we do have the what? The weight, we can calculate the mass. Remember that Fg is equal to mg. Okay, so sesinayo ke ngoku Fg weight, which is 1205,4. Imass lesifunayo, then uji 9,8, then we divide by 9,8. So the mass now is equal to, let's press the calculator, is equal to 123 kgs. This is the mass. Now let's go to another question, that is question 4.2. Calculate the combined mass. We're done with this one. Now they say the helicopter now starts to accelerate, which means now acceleration is not equal to 0. Acceleration is 2.25 meters per square second. Upwards. Calculate the tension, which means we are going to have a new tension, but the free body diagram is the same. Tension is positive, Fg is negative. So we are going to say F net, as always, is equal to ma. Okay, so we have tension minus Fg, which is equal to ma. Fg besimbalile u-FG nankuya, so sizove simthathe xa sizomfaka u-FG bese simbalile. The tension is what we're looking for. FG is that 1205,4, which is equal to the mass. The mass is 123. This is the mass. 123 times the acceleration is 2,25. Let's go back. It accelerates upwards, which means upward is positive. Then we press calculator. Let's press the calculator. So the tension is equal to 1479,69 newtons, which means they increase the tension. Therefore, the system accelerates with 2,5 to 5 meters per square second. Then we are done with question number 4. Let's go to question number 5. Question number 5. This is question number 5. A moon is the Earth's nearest neighbor. So we have the moon here. This is the moon. Let's say this is our moon. Then we have Earth. Let's say this is planet Earth. Earth is bigger than the moon. So let me try. So now Earth weight, okay? So they say the moon is the nearest neighbor, is the Earth's nearest neighbor. The distance between the center of the moon and Earth. This is the moon, this is Earth. The distance between the center is given as 3,84 times 10 to the power 8 meters. The mass of the moon is given as 7,5 times 10 to the power 22. Okay, which means we also need, this is the mass of the moon, that is M. We also need the mass of Earth. The mass of Earth is constant, so we are going to check it on the constants. Let's go to the constants. So these are the constants. So this is the mass of Earth. Okay, it's not writing. Okay, this one is a mass of Earth. That is 5,98 times 10 to the power 24. Let's go back. So which is equal to 5,98 times 10 to the power 24. 5,98 times 10 to the power 24 kgs. That is the mass of Earth. Okay, 98. All right. Now let's go to the questions. The first question here says state. Where is it? State Newton's law of universal gravitation. That is, the formula is F is equal to G m1 m2 divided by r squared. So this is a gravitational force. The gravitational force between two bodies is directly proportional to the product of their masses and inversely proportional to the squared distance between their centers. So the gravitational force is directly proportional to the product of their masses and inversely proportional to the squared distance between their centers. Calculate the force exerted by Earth on the moon. By starting with force, we are going to use this formula, okay? G is a constant. Naguchi 6,67 times 10 to the power negative 11. So G constant, G is constant 6,67 times 10 to the power negative 11. That is G. Let me confirm. 6,67 times 10 to the power negative 11. Now let's calculate. That is 5.2. So 5.2 is equal to, sibale 5.2. F is equal to G M1 M2 divided by R squared. So this is body 1, this is body 2. So G is equal, or F is equal to G, which is 6,67 times 10 to the power negative 11. That is what you do. Then imass yokuqala ngubani? 7,5 times 10 to the power 22. Then imass yesibini ibe ngubani? Ibe yile, which is 5,98 times 10 to the power 24. Everything is divided by the distance between their centers. This is the center 1, this is center 2. The distance is 3. Remember, there's that square, 3,84 times 10 to the power 8 square. So it's wise about vuli brackets. Then stop your calculator. That is the force. Look at the force. So the force is 2,08 times 10 to the power 20 newtons. That is the force. Then we are done with question number 5.2. Let's go to 5.3. 5.3 says, what is the magnitude of the force exerted by the moon on Earth, and explain. It will be the same as this one. That is that 2,0. It was 2,08. 2,08. 2,08. So 5.3, the answer is 2,08 times 10 to the power 20 newtons. Raising Newton's third law. Newton's third law, which says the force exerted by object A on object B is equal to the force exerted by object B on object A in the opposite direction. Alright, then let's go to question number 6. So this is question 6. Question 6 ke ngokuyena uthi under electrostatics. So sina spheres 2 that have a mass engubani engu-5 kgs. Then i-charge yokuqala nansiya. Then sibe ne-charge yesibini. Then the forces, they say both spheres come to equilibrium. Then what we know is that equilibrium F net is equal to 0 there, newtons. There is a distance between them. This is the distance, this is the distance. Okay, now let's answer the questions. The first question says calculate the number of electrons on 1 to give it that charge. So that is 6.1.1. Number of electrons, Q over QE. That is Q1 in this case. Q1 is 4,5 times 10 to the power negative 9 divided by QE is negative, but since this one is positive, we write positive. 1,6 times 10 to the power negative 19. Then the number of electrons, the calculator says 2,8 times 10 to the power 10 electrons. Then we're done with this one. Then the following question says draw a labeled free body diagram. Since this one is positive, lay negative, there is a force of attraction. So we have force, electrostatic force, that is force between 1 and 2. Then this one also have FG. It also have a what? A tension. It question, draw a label free body diagram showing all forces acting on Q1, which means the free body diagram will be this one, tension in FG, so that is 6.1.2. so the free body diagram, tension is going up, then downwards we have two forces, which is FG and the force between 1 and 2, that is electrostatic force. The following question says, state Coulomb's law in words. Coulomb's law states that electrostatic force between 2 point charges is directly proportional to the square, directly proportional. It is directly proportional. That is, electrostatic force is directly proportional to the product of the magnitude of the charges, and inversely proportional to the squared distance between them. So uzombhala in words here wena as one sitcho. Then we have 6.1 point, this was 6.1.3, 6.1.4. Calculate the magnitude of the tension. So this one is very easy. We're going to use this one. We said F net walapha ngubani ku 0 newtons, meaning that it's a tension which is going up. This one is negative, this one is negative. So it's net tension minus Fg minus F12, which is equal to 0. So it's leno masiqale ngosibale bani force between 1 and 2, which is K, Q1, Q2, because the electrostatic force layer. Then K 9 times 10 to the power 9 constant. Siyojonga Q1 phezulu kwi-statement, Q1 now Q1 4.5 times 10 to the power negative 9, lena ngu-2.5. so Q1 4.5 times 10 to the power negative 9, then Q2 2.5 times 10 to the power negative 9 also. Then divide by distance between them. Let's go to the statement. The distance is 3 centimeters, which means masichinje ke ngoku i-distance lady in meters. 3 divided by 100, we get 0.03. Then let's press the calculator. Siyifumane i-force. So i-electrostatic force ke ngoku yona ibe ngu 0.00012 or 1125 newtons. Then sibale Fg. This is F between 1 2, then Fg is equal to mg. The mass is 5 grams. This is 5 grams. So see change basic kilograms. So let's change it to kilograms mass. So the mass is 5 grams. We divide by 1000. Is about 0.005 times 9.8. Then let's do a calculator. 0.049. Then this is also substitute here. Let's substitute. The tension is required. Fg 0.049 minus the force between 1 and 2 was 0.001125 newtons, which is equal to 0. Then stop the calculator. Therefore, the tension is equal to. That is the tension. Then let's go to another question. Oh, that was the last question there. magnitude of the tension 6.2. 6.2 hamba kanje. So hamba kanje, 2 point charges, that is S and T, are placed at 0.5 apart as shown in the diagram. S carries a charge of for 5 and T minus 30. Then A is 0.1 meters to the right of point charge T. Okay, this is A. A is a test charge. Okay, the first question says define electric field at a point. Electric field at a point is defined as a force experienced per unit positive charge. Electric field at a point is a force experienced per unit positive charge. Draw the electric field pattern. So this one is positive, this one is negative. So it's no positive, it's no negative. There is a force of attraction. And then the arrows is here towards negative, then away from positive. This is 6.2.2. Then 6.2.3, and to calculate the net electric field at point A due to 2 point charges, 6 marks. So we have these steps that we follow. Step number 1, you draw the force diagram or free body diagram. Step number 2, you calculate each force. Calculate each force. In this case, each force or electric field. Electric field. Step number 3, choose direction. Choose the direction. Then step number 4, calculate. Then step number 4, calculate F net or E net. So we are going to follow the steps to answer this question. Okay, let's start with step number 1. Step number 1 says draw the force diagram or the vector diagram. Perfect word about vector diagram. So if you want to have a positive and a negative, so there is a force of attraction. The focus is here. A is positive, T is negative, therefore there is a force of attraction. A uzoya towards UT. That is electric field to UT. Then this one is positive, this one is positive, repulsion, so there is a lay because of US. Which means sine diagram to vector diagram. Any electric field that is T, electric field that is S. Then number 2, electric field at S and T. So electric field will be equal to KQT, if I'm starting with T, divided by R squared. Now K is 9 times 10 to the power 9 times UT with 30, 0.1 away, microcoulombs, with 30 microcoulombs. Then we multiply by 10 to the power negative 6 because of micro. Divide by the distance is 0.1 square. Then we press calculator. Let's also substitute ASB. This one is for T. Here we got as it's 9 times 10 to the power 9. Then strong S. U-S plus 45. Lo 0,15 nalo 0,1. So 0,15 no 0,1 ngu 0,25, okay? So the charge is 45. Micro 10 to the power negative 6 divided by 0,25 square. Now let's press the calculator for both. So with the answer nalena, that is electric field as a 2, that is electric field T nobani no S. Then let's take right as positive, then this one will be negative. Therefore E net will be equal to ES minus ET. So ES is 648,000. This is the value. Minus T 27,000,000. That is 27 million. That is this one. Then we press the calculator there. So it's finally the answer, which is negative. Therefore, we conclude by saying it's 20,520,000 Newton per coulomb. Since it's negative, we said west is negative. City west. Then specify the question. Then that is the last question. You get 24 marks. Let's go to electric circuits. That is the last question of this question paper. Electric circuits. In the diagram below, a battery has an EMF. So we're given the EMF and a negligible internal resistance. Okay, so we are going to answer the questions here. So this is the current. The reading on ammeter is known as current. That is the total current. We are going to get the total current. To get a total current, you need the total resistance and the total voltage. In our case, in this case, E voltage is total 6 volts because that is the EMF. Okay, now let's go to questions. The first question here says, calculate the effective resistance. So if it's not stronger, this is the series. So that's where between the series. Then let's figure out the split, which means this one is parallel, this one is parallel. So as is we choose on this series, that was divided as square of 6. It's parallel to 3. Okay. So 7.1.1 1 over R parallel will be equal to 1 over R1 plus 1 over R2. As now you are series in this case, it's not parallel because A is divided series. The 6 parallel below 3. So it is no 1 over 6 plus 1 over 2 or 3. Then let's press calculator. Then we get the answer per. So the answer is 1 over 2. 1 over 2. Then cross multiply. 1 times RP, it's RP. 1 times 2, it's 2 ohms. Which means the total resistance of this circuit is 2 ohms. The total resistance of this circuit is 2 ohms. The total resistance is 2 ohms. Okay, the total resistance is 2 ohms. The following question says, the rating on A1, this is A1, that is total current. So this is 7.1.2. The total voltage is what? is 6 volts. Total voltage is 6 volts. Total resistance is 2. We are looking for the total current. So we can use R is equal to V over Ri, the formula. So the resistance is 2, V is equal to 6 over the current is what we are looking for. Okay, then we cross multiply. 2 times I is 2I, which is equal to 1 times 6 is 6. Then we divide by 2 both sides. I is equal to 3 amperes. So the total current is 3 amperes. That is 3 amperes. So the following question says calculate the reading on AU2 here. So we need the voltage. Since this one is parallel to this one, the voltage elapha kulo 6 ewonke, that is ekule ntambo, is equal to this one, which means apha ngubani? Apha ngu-6 volts. 6 volts lapha, because uparallel uyafana right through, since kungekho series, therefore 6 volts. Nalapha izoba ngu-6 volts. Therefore singakwazi ukumbala ke ngoku i-reading on A2. Let's collect the data. Reading on A2. So the resistance there is 6, then the voltage there is 6. Therefore, the current will be equal to, we're going to use R is equal to V over I. It's not 6 here. V is 6 over I. Then we cross multiply. 6 times I is 6I, which is equal to 1 times 6, which is equal to 6. Then we divide by 6. Therefore, I is equal to 1 amperes. Which means the current that moves here is 1 amperes. The following question says, masibale ke ngoku power here. Power here. Ku-4. What we have here is a current M1 emuva pha. So let's collect the data. We are looking for the power. We have the resistance. The resistance is 4. The current is I. So let's go to the formula sheet. So we have a power. We have the power, current, resistance, which means we're going to use this formula. Okay, let's go back. So power is equal to I squared R. You have 1 squared times 4. Then 4 watts. Then the question is answered. This question exactly is rated 150 watts. Calculate how much a learner will pay for electricity for using the kettle for 4 hours. ESCOM charging 1 kilowatt hour. Charges 1 kilowatt hour electricity at 2.05 rand, 2 rand 5 cents. So we want to know after 4 hours this will be ingakanani. imali ezobe ispendwe ngumfundi. So zii-tariffs ezi, that is 7.3. So if you can look here, they say 1 kilowatt hour is equal to xa uyithengisa 2.05 hours. Now we're given the power, which means let's change this power to the kilowatt hours because this one is hour. So we're given the power, which is 1500 watts. Let's calculate the energy in kilowatt hour. Remember that power is equal to energy divided by delta T. That is the power. So if we want energy, we can cross multiply. As for the energy in kilowatt hour, so let's substitute with 1500 watts, which is equal to the energy, let's see, divided by how many hours? 4 hours. Then let's cross multiply. Now the energy is so 1500 times 4 is 6,000 watts hour. But remember that nalo cake, which means we can just divide by 1000 to introduce like a. Then we get energy, which is 6 kilowatts hour. Now the price for 6 will be equal to 6 times 210 or 2 rand 5 cents. Then umfundi abe usebenzise, that is the price. Abe umfundi usebenzise 6 times 2.05. 6 times 6. Abe usebenzise imali engange 12 rand 3 cents. 12 rand 30 cents, I mean. So ilula kanjalo, since we are given 1 kilowatt hour, price yayo kuthiwa 2 rand 5 cents. Wena ozoyenza ipower oyinikiweyo uzothi power is equal to energy divided by delta T. This is the energy. So sibale energy. So ipower 1500 watts, which is equal to energy over ixesha lethu phaa kuthiwa 4 hours. Then if we cross multiply, the energy will be equal to 6,000 watts hour. Ushota bani ke ngoku K. Then you divide by what? By 1000. U-introduce la K ibe ngu-6 kilowatt hour. So ilula ke ngoku sebekuxelela uba i-kilowatt hour eyi-1 imalini, i-2 rand 5 cents. You'll just say therefore i-cost price yomfundi will be equal to 6 times the tariff price leya ingu 2.5, then 2.05. Then you get 12 rand 30 cents. Then sigqibile ngoku le question. That was the last question of this question paper. Don't forget to subscribe. Don't forget to comment. You can comment, say anything, ask question. Follow me on Facebook, Lukhona M Sciences. So please share to your friend. Thank you. Bye.